The last thing we talked about before the end of class was polynomial terms. We talked about monomials, binomials, trinomials, and polynomials. Now, we got to actually cover some definitions for that introduction. So let's write polynomials. And there's a few definitions we got to cover. So the first definition we're going to go over is the word degree. What is a degree? It's going to be the highest exponent in your polynomial. So, for instance, if I give you the example, 3x to the 7th plus 4x to the 10th plus 2, we're going to say the degree of this polynomial is equal to 10. Our highest exponent is 10. So I'll be using the word degree pretty often when I talk about polynomials. The next thing we got to worry about, so degree is the exponent in your polynomial in this case. So now we got to talk about other parts of the term. So the first part of the term we got to talk about is called the coefficient. Some of you guys might have heard what a coefficient is. Coefficients are constants in front of variable slash factors. And I say variable slash factors because it could be in front of a factor that is not a variable. And we'll get to more into that later on. But the easiest example I can give you is 3xy squared. Your coefficient is going to be the number 3. So these are two definitions. We got about two more to go. Next definition after degree and coefficient is factors. So I told you that, hey, for a coefficient, it's got to be in front of a variable slash factor, but I never told you what a factor is. So we're going to formally define it as components of products. And in mathematics, when you think of the word products, you should think about multiplication. So, example, 3 times 5 will give you 15. Your factors are these two factors. These are your factors of 15. Now, there are other factors of 15, but in this example, 3 and 5 are your factors. Of course, there's also 1 and 15, but I expressed it as 3 and 5. Now, your factors are going to make up the term. They're going to make up the term. These guys make up a term. So now that we got that out the way, we can go to the next thing we can talk about. So, when we're doing any sort of polynomial, there's a little remark that I want you guys to always remember. Polynomials should be in descending order. They should be in descending order. And what that means is highest expo to lowest. Should always have them highest to lowest. So in an example, you should have something like 3x to the 7th plus 4x to the 3rd plus 2. You can see that the exponents for each of the x's go down in order. Now, I am skipping a couple like x to the 6th, x to the 4th, or whatever, but the exponent decreases for the x value. Now, you don't see an x on this too, but you can also think this as x raised to the 0th power. Because x raised to the 0th power is 1, and 2 times 1 is 2. So you can also think of that. That will come and play a part in our problems later on. So, moving forward, now we need to talk about the next definition. Or do I want to go with the definition or not? like terms. Let's talk about the last definition. Like terms. So when you're talking about terms, there's something called like terms. Like terms, they're going to be terms that have the exact same factors. It has to be exactly the same factors, including exponent. Except there's only one exception, and that's the coefficient. The coefficient. Your coefficient can differ. So the constant can differ, but your variables and your exponent should not. Example, 2x to the fourth plus 3x to the fourth. These guys are like terms. This is x to the fourth, and that's x to the fourth. Bad examples. These are some bad examples. So a bad example would be 2xy plus or 2x squared, or just 2x. These are not like terms because this guy has an xy. However, this term only has an x. They are not like terms. They even share the same coefficient, but because the other factors outside the coefficients are different, we cannot call them like terms. Another example might be, that's a bad example, 2x squared plus 3x to the fourth. Even though these guys have x's in them, because the exponents are different, they are not like terms. So now that we got the definition of like terms, we can actually apply it. So let's apply it in an operation. In particular, how to add polynomials. So how do we add polynomials? It's very easy. Combine like terms. And when I say combine like terms, that could be add, subtract, or whatever you see. So combine like terms. So example, let's say we have 3x squared plus 5x to the third plus 2. And we're going to add that with 2x to the fourth plus x squared plus, or let me do subtract, apologize, minus 7. All right. Looking at this problem, our like terms, let's look at x to the fourth. Well, x to the fourth, there's no other like terms with that, 2x to the fourth. So we got to move down the power. So our first like term is actually going to be plus x squared and 3x squared. Our next like term is going to be positive 2 and minus 7. Notice how I am actually circling the sign as well in front of the number. This minus sign belongs with this 7. So instead of thinking of it as a subtraction symbol, think of it as a negative 7. They mean the same thing. So if we combine our like terms and move down what we need to do, notice that 2x4 doesn't have a like term, so we got to drop that down. This is the highest exponent. And remember, we're putting in descending order, so we're going to put the highest exponent first. The second highest exponent is 5x cubed. Well, that also doesn't have a like term, so we can just drop that down. Now, in red, our x squares, they do have like terms, so we got to combine them. 3x squared plus x squared. Well, because there's no number in front of the x, we can treat it as 1. So, how do we combine like terms? Well, we're going to add only the coefficients. So when you're combining like terms, you should only add the coefficients together. In this case, it's 3 and 1. If I add them together, I get 4. And when you add the coefficients, the factors stay the exact same. So this stays 4x squared. Do not change the factor. Only the coefficients will change. And then the last one, positive 2 minus 7, that's going to be minus 5. You got to work with your negatives. And that is how you combine like terms. This is how you add polynomials together. You got to make sure, hey, does this factor match up with this factor? The moment they do, you can add them, subtract them, whatever. In this case, we're going to be adding them. So I encourage you guys to try this out and more practice and whatnot. So let's go to the next one. We deal with addition. Now we got to deal with the harder one, subtraction. How to subtract poly. How do you subtract polynomials? Well, I've always told you that we don't like to deal with subtraction. Instead, we deal with addition because subtraction is just the inverse operation of addition. So, if I were to give you an example, 3x squared plus 5x minus 2, and I'm going to subtract that with this guy. 4x cubed plus x squared minus 3x plus 1. I've never taught you guys how to subtract. I've never. However, let's look at this problem. 6 minus 3. 6 minus 3. Well, we have to agree that this is equivalent to 6 plus negative 3. They are going to give me the exact same answer. 6 minus 3 is 6 plus negative 3. Why? Because the negative belongs to the 3. So you can always think of it like this. And if you use this model right here to our problem over here, what that means is that, hey, this problem is going to be the exact same. However, we're going to turn that subtraction into addition. And in doing so, I have to distribute this negative out. Same thing with here. To turn the subtraction to addition, I turn the subtraction into addition, and I turn that 3 to negative 3. It's the exact same procedure. So we got to do negative of 4x cubed, which is negative 4x cubed. We got to do negative of positive x squared, which is minus x squared. Negative of 3x, which is positive 3x. And then it's going to turn to minus 1. Now, I encourage you guys to do this method because although it's tedious, it leaves little room for mistakes. And a lot of students will make this mistake on a test or quiz. So, moving forward, now this becomes addition, but we're comfortable with addition. So let's get our like terms. 3x squared. The like term with that guy is minus x squared. Well, another like term we have is positive 5x and positive 3x. And then the last like term we have is minus 2 and minus 1. So now let's write our highest exponent first. Let's write our degree or our term with the degree on. So that's going to be the minus 4x cubed. However, there's no other like terms with that, so we just drop that down. Now, the next highest exponent is 2. So we got to add the pink circles together. 3x squared plus negative x squared. If you don't see a number, put a 1 there. So that's going to be plus 2x squared. 3 minus 1 is 2. Then we move on to the next degree, the red ones. 5x squared plus 3x is going to be 8x. And then we add the final piece, which is going to be minus 3. Boom. That is how we subtract our polynomials. I encourage you guys to try this little practice on your own free time. You guys can try out 5x to the 4th plus 3x squared minus 2 subtracted by negative 5x to the 6th power. Oops. 6th power plus 5x to the 4th minus x squared and then plus 1. I encourage you guys to try this as an exercise. Try this as an exercise, and if you are stuck, you can come by my office hours and let me know any questions on this particular exercise. So moving forward, if you notice from our last chapter, or last section, I apologize, we talked about radicals and exponents. But there was a key thing I took away from last lecture, and I'm going to be talking about in this lecture for a reason. So before we even go on to that, I need to make sure we do some little review. Just to make sure that, we're all fine and dandy. So, let's talk about multiplying real quick. If I multiply this radical over this radical, well, I can't do the factor tree just yet because I could technically. However, that makes the process much longer. let's actually simplify this by multiplying it out. If I multiply radicals, the inside multiplies the inside, the outside multiplies the outside. Well, the outside is just a 1 and a 1. And 1 times 1 is itself, so I don't even have to put anything there. Now, if I multiply the inside of the radical, that's going to be 150. Now we can do that little factor tree that we've been always working with. This is a 5, by the way. If I do the factor tree, well, I get 15 and 10, obviously. I get 3 and 5. 5 and 2. I say obvious because these were these numbers that we multiplied initially. And then if we do our factor tree, well, the index here is assumed to be 2. It's assumed to be 2 if you don't see it, which means I need pairs of the exact same prime numbers. And there's only one pair of prime numbers that I see here that are the exact same, and that's going to be 5. Well, what does it mean? This means that, hey, I get a single representation of 5 outside the radical. Everything else, every other prime number goes inside, which means I have 5 root 6. That's for multiplication. I want you guys to understand that is multiplication. Now we have to move on to something that is related to what we just talked about. Adding radicals. We got to know how to add radicals together. So let's take this problem right here. Square root of 24, and I'm still doing index 2, plus, let's do 3 root 6. Square root 24 plus 3 root 6. Well, let's treat this like a polynomial. If this was a polynomial, to combine these guys, or to add them together, we need to have these terms as like terms. So when you have them as like terms, what are you going to do? You're going to add the coefficients. The coefficient of this guy is 3. The coefficient of this guy is 1. However, there's a problem. They are not like terms. Remember, like terms, or like terms in general, means that your factors have to be completely the same. Factors slash variables. And I use a slash because in this case, it's going to be our factors. Is square root 24 the exact same as square root 6? No. So we cannot combine these guys. However, I will say we can combine them. Even though they're not like terms, we can somehow turn them into like terms so we can combine them. So I'll give you guys a few seconds to think about how you guys can actually turn this into like terms, even though square root 24 is not square root 6. All right, so if you haven't figured it out, what you can do is actually do the factor tree of 24, which is 12 and 2, 6 and 2, 2 and 3. And then because the index is assumed to be 2, we're going to get pairs. Boom. Now, when I drop this over, this 1 was multiplying the square root 24 in the first place. That must be in our problem. You cannot delete that. So we have 1 times, now we have a single representation of 2. So 1 times 2, square root. Every other prime number in our factor tree that did not have a pair will go inside our radical, which is 2 times 3, which is 6. So now once we simplify this out, 1 times 2 is 2 root 6 plus 3 root 6. Well, what do you guys notice now? The coefficients might have changed. However, something even more important happened. We have liked terms. These are the exact same factors, which we can go and add them together like polynomials. And when we're adding them together, all we have to do is add the coefficients. So when we do that, we get 5. Once we add the coefficients, the factors stay the exact same, root 6. That is how we add radicals. So if you're confused on how to add radicals, treat it like a polynomial. Sometimes you cannot simplify it any further. However, first try to see if you can factor tree it. If you can factor tree it, maybe it might come out nicely. So as a little exercise for this, you could try at home. I encourage you guys to try this one at home. 2 root 50 plus, let me do minus, I'm sorry. Minus root 98. I encourage you guys to try that one out to see if you're confident in doing these operations. And the main thing I want you to get out of multiplying and subtracting is to notice the difference. Notice, Because some people will make that mistake. Difference between 2a squared b cubed times 3ab and 2a squared b cubed plus 3ab. I want you guys to notice the difference between multiplying and adding. When we multiply these out, hey, 2 times 3 is going to be 6. Now, a squared times a. Well, technically there's an exponent of 1. And if we're multiplying terms that have the same base or factors with the same base, we're going to add the exponent. So instead of a squared, we have a cubed. B to the third times b to the first power, we're going to add the exponent as b to the fourth power. Boom. Now, for our bottom part, when we're adding some factors, if they are not like terms, this is already simplified. This is what I want you guys to understand. Simplified. I want you to understand that, hey, multiplication, generally we can work with that. However, with addition, if they are not like terms, sometimes we can't work with that at all. It's like adding apples and orange. You can't do that. However, you can multiply them. So, moving onwards. Now we get into some fun stuff. So I told you about addition. Now I'm telling you about subtraction. Then we have to move on. How to multiply polynomials. We gotta know how to multiply polynomials. So, for instance, we have x times x plus 1. Well, in this case, we have a nice little property that we talked about. Distributing. If we distribute it out, x times x, well, they both have a power of 1. 1 plus 1 is 2. X squared. X times 1 is itself, so we're going to have plus x. So we can distribute. However, sometimes you're not going to have a monomial. Mono means 1. This is a monomial times a binomial. Sometimes you might have more. In particular, we're going to talk about, hey, what if I had a binomial times a binomial? Binomial times a binomial. Well, we're going to treat this as the exact same thing, but notice that, hey, if we distribute this x out, we get x squared minus 3x. This minus sign belongs to the 3. Boom. But we're not done. We didn't do that portion that I erased off, which was the plus 2. We didn't do that plus 2. So now we got to multiply that guy out. Oops, sorry about that. We got to multiply that plus 2 out. Because there's 2 terms. It's not just one single term. It's 2 terms. So we got to multiply this plus 2 with x and with minus 3. And plus 2 times x is positive 2x. And then 2 times negative 3 is going to be minus 6. And then we got one last step. We got to combine like terms. Well, these guys are the like terms here. So if I combine those together, I get minus x minus 6. Or minus 1x. Either or is fine. And the key thing here, this is a method called FOIL, which stands for first, which is going to be the first things in our parentheses, x times x. Then it's going to be outside. So you're going to multiply things at the very edge of your parentheses. So x times minus 3. That's outside. And then it's inside, which are things going to be which are terms that are in the center of your parentheses, which is 2 times x. And then the L stands for last. We're going to multiply the last terms in our parentheses, which is positive 2 times negative 3. That's a way to systematically think about this. Now, some students are comfortable with the area model, or they can draw these arrows on the fly. I don't care as long as you have a method. Now, there needs to be some work shown. However, as long as I see a method, you are fine. So, this direction, if I'm going from distributing out to the expanded or to this long mess over here, this is called expanding, if we remember from previous lessons. If I go in the other direction, let's say I have the same problem x squared minus x minus 6, x squared minus x minus 6. Oops. This direction is called factoring. We will go more into detail in the next lesson. The next lesson will strictly be about factoring. However, this is the process. We're going to go backwards. I'm going to have a lot of building blocks or Legos, and then my goal is to break up the Legos into smaller pieces. All right, so that concludes today's lesson.